Good morning. Welcome to another episode of XR Talk Show. We need to talk, and there are a lot to talk about. So let me show you what I'm gonna talk about. Today's topics. So let's go to. I'm just going to show you what we're gonna talk about. We are going to talk about JavaScript string problem, and and I'm going to explain what is the problem and what is JavaScript, what does it mean to have a code unit, what does code point mean. It's related to Unicode. Then we are going to talk about category theory for you Haskell fans. But actually, I'm going to talk about something related to mathematical logic, the math logic branch, which is about related to proof theory, model theory, category theory, logic, symbolic logic, predicate logic, first order logic. And, for example, let me show you some Wikipedia articles. So modal logic. So this is modal logic. Let's magnify. So we have modal logic. Good morning, Isaac. Hurrah. So we have modal logic. We have Lindstrom's theorem. We have load. We have first order logic. We have interpretation of logic, which means a model. When we say something, I'll do some explanation a little bit because I'm not really qualified to teach this subject. And then we have standard model of arithmetic. Nah, that's too advanced. I don't understand. So I'm gonna talk about these few things, okay? And if you are new here, the format is we got 3 people watching. All right, yay. So the format is you ask, I talk, okay? And right now I'm going to drink this coffee. I'm gonna drink this. This is cheap coffee. It looks like Starbucks. This is $1 in Dollar Tree store. So we're gonna talk about JavaScript and some math and some stuff and stuff. That's what I'm gonna talk about. Break the loop. Good evening. Great to see you. So break the loop says, what do you think of replies you got on Twitter about Unicode in JavaScript? Yeah, that's the topic I'm going to talk about. So let's begin. But as usual, I am going to digress. I'm going to show you this for 2 minutes. Okay. Now this is a castle home. This is real. This is not toys. You got this like Disney style castles. You got hundreds of them. Where are they? They are at this Mudanu in Turkey. So apparently some real estate or some rich people, they build this bunch of castle homes, homes in the style of a castle, and they want people to buy, but for some reason the market is down or the economy turned down, and so they became a ghost town. So you have all these castles, hundreds of them, and nobody's living there. So I mean, if you search the web, Muduru Turkey Castle, or go to Reddit, you'll find more information. In fact, today there are so many photos. Like all the website, they want your money, they want ad money. They want you to visit. So there are tons of website, having beautiful photos of these architectural stuff. And by the way, as you know, this is part of my architectural beauties website, which is part of the xararts.org. Okay, this is my local copy. So I started to collect these. For example, the first one is written around 2006. So that's like 15 years ago. And because they are beautiful. By the way, back in 2006, you don't have that much websites. Wikipedia just began like 3 years ago, and it's in its infancy. As we say, so there's not much anything. So I began this to collect these architectural photos, beautiful architectures. And look at this one, it's spectacular. It looks like a dream from science fiction. But this one is actually in India, uh, Ganges River or Gans River. I don't know how do you pronounce it, but in India, it's so it's beautiful. The world is huge. You know since today, in our digital age, we begin to see so many things. I mean, yeah, well, that's an old topic. So like we can see everywhere in the world. And like, you go to Google Earth, you can see almost just about every city streets photos. Billions upon billions of photos. Good evening. So that's a digression, and let us get back to JavaScript, shall we? Is it good? Anyone? Everyone? Good. 3 people watching. Okay. 3 people. 3 is lucky number. So let's close this Xa Talk show. That's right. Let's open that. Now let's talk about the JavaScript problem. Cheers. So how is going? Break the loop. So you did study Java, Java language. I don't like. So you did. So let's talk about JavaScript. Okay, Isaac, do you program in JavaScript? I don't think you do, right? Okay, let's talk about JavaScript. So what is the JavaScript issue? Now look at this. Now just look. Now I'm going to demo. Okay, let's go to Emacs. So let's open a new buffer and save this file as xx.js. So it's a temp file. And let me show you what's the issue with JavaScript. Okay, it's kind of surprising issue. Okay, since I'm using Emacs, let me start start command log mod. Okay, so you can see all my flag keys commands in this window. So I'm going to go to JavaScript JavaScript mod console log print and make a string, and let's see what smile no okay, let's go to abbrev. I forgot what's my abbrev for that character. Okay, there it is. Horror, cat face, no. Well, for a change, let's use this one. No, I want to use the clown. Okay, clown. Okay, you see a clown? Hold on a second, magnify. You see, we got a clown character. And let's say what is the length. Okay, wait. I'm sorry, but the clown character is really just too big. I mean, too complicated to see well. So let's switch back to the crying with tears of joy. So Isaac says, "Oh, what do you think about free non-proprietary software?" I think it's good. Because mostly because I think open source has become a ideology and a bad one. So you know, I mean, I mean, you've been here. I mean, you guys know I talked about this quite a lot. So I mean, today we got lots of other topics. So anyway, so let me read some comments. I see clown crying with the tears of joy is the best. Hey, King Herring. Haven't seen you before. Good morning. Good evening. Oh, are you from Germany? Your name reminds me of from German, because I think German names got this her something. So anyway, let me show you. Let's go back to JavaScript. So you have this character, okay, tears of joy. Okay, and you want to see how many characters are there. So let's run the program. Run it. Now you see the result is true. How idiotic. So let's see, equals to true. It returns true. You can see that true. So this is what I mean by JavaScript problem. Okay, this is like a very very stupid. Like as a programmer, every day we work as a programmer, right? And you encounter all these hacks and problems and so on. And every day you spend time to debug, and then you have a bunch of crazy things, patterns and shit like that. Agile, voodoos of programming and Unix philosophy. Okay, I hate the fucking Unix philosophy. Those are voodoos. This is you see, this is one example. You see, you got this voodoo. But why does it happen? Okay, well, it's complicated. But we're gonna explain. So this is a problem. Okay, let me show you some other examples. Then so here are some other examples. Okay, so let's go. Hold on a second. Let me shrink this. This is too big. We don't want it too big. Okay, that's good. So let's do that. Paste, paste. So we have that. Let's put it here, and let's put it here. Okay, now let's run this. All this returns true. So basically now I have a string, and I want to use the method pad start, meaning like I want to pad x in front of it, and I want the total length of the string to be 2. So I'm expecting x smiley, but instead it returns just smiley. Why? Because this smiley character is already has a length of 2. Now here's another example. We take a slice. Basically we want a substring of this string, and so substring from 0 to 1, which should give us that character. However, it's not equals to that character because for example, let's do this. Let's see what it returns. You see, you got this this non character, this half-assed botched character. So this is what I mean by JavaScript string problem. So in fact, all string methods in JavaScript have this problem. This is really a serious problem. I mean, it's incredible. It's like, if you are a programmer, you think, why have we such of this extreme complexity, this idiotic, utterly stupid. This kind of situation permeates throughout the programming industry, technology. Unix is the worst fuck. Okay, Unix and Linux permeates throughout the industry. Almost every technology, Unix and web dev, especially web dev, JavaScript, DOM, technologies. It's like all these kind of stupidities, and we have to endure it. That's our job. That is our job. So okay, let me just talk about this. Let me not digress too much. Let me finish this one discussion. Okay, let me read a comment a little bit. Do you know about Terry Davis? Yes, someone asked about that, and actually I talked about that 2 weeks ago, something like that. So he's got schizophrenia, meaning that he see illusions. He see things that's not there. He hear things. So he's got. Anyway, I talked about that the other day. I'm a Czech American. Oh, okay, cool. So Break the Loop says, is it weird bug of Unicode in JavaScript? No, it's not a bug. Okay, let me explain. Oh, you interviewed Terry Davis. Oh, do tell us the story. But okay, let me focus. Let me focus on finishing talking about the JavaScript. Then, if you have a comment about JavaScript, then I'll talk about that. Other comments, I'll I'll look at after I finish talking about JavaScript. So anyway, so JavaScript, you got these problems. So why does it have this problem? It's not really a bug, but actually it's fairly complicated. It has to do with the history of Unicode, the history of adoption of Unicode in programming languages, and technical details of Unicode in coding. Okay, so let me explain a little bit. So first of all, the problem, you can understand, you can see the problem. This problem, when you have a string of single character, but it actually has a length of two, that is a problem. And this happens for all string functions in JavaScript. Yeah, so it means whenever you want, and this is a problem only when your string contains a character that is emoji, or whose code, or your string contains a character whose Unicode code point is beyond 2 to the 16th power. I'm going to explain them. But anyway, so the simply put, you have problems with all string functions in JavaScript. Unexpected results whenever you have an emoji. Okay, that is a problem. Now let me explain why this happens. Okay, let me just answer that quickly. The reason it happens is because JavaScript string, when we see a string, for example, A, B, C, D, you know, we think, it's just a sequence of characters, right? But technically, you know, technically, the real actual definition, what it means is a bit complex, because what do you mean by character? What do you mean? What is a character? If you use a pen to write ABC, obviously, you know what is a character. But once you use a computer, it's hard to say what exactly is a character. So 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 let me so anyway, the reason this problem happens in JavaScript is because JavaScript string is actually technically defined as a sequence of 16-bit code units. Okay, so it's called code unit. So each character you see here is considered, it's called a code unit. It is actually, so what it actually is actually just 16 bits, binary number, 16 of them. So why is this smiley has length of 2? That is because this character, Unicode character, when it is encoded, it actually has 32 bits. So two 16 code units. So that is actually considered two units. So that is why this smiley length is 2, and for the same reason, all the string method does not work as you expected. Okay, so that is the reason. Now let me explain about Unicode. Uh, okay, so Unicode code unit. So okay, let me go in detail then about this JavaScript problem. Okay, so to understand it in detail, you have to understand JavaScript string is a sequence of 16-bit values. That is a technical definition of a element in a JavaScript string. Okay, so each element is actually 16 bits values. And so when you use an index, for example, when you use an index of a string, for example, when you do slice index of a string, the index actually means each of the 16 bit values. It does not mean a character. So on this page I give the detailed explanation, but so basically let me just kind of go over it. So Java string and character are based on Unicode standards version 5.1 or later. Okay, today the current version is Unicode 12. I think 11. Yeah, Unicode 12. I think. Each Unicode character from the Unicode standard, each Unicode character has an ID, integer ID code point. Okay, so this is an important concept. So each character has a ID that's called code point. Now Unicode specifies several encoding standards. The two most popular ones are UTF-8 and UTF-16. So what does encoding mean? Encoding means you want to turn a character into a sequence of binary bits. That's what encoding means. Of course, there are many ways to do that. For example, you can say, the character A, you can say, it should be encoded as 110011, for example. You know it's kind of arbitrary, but there are some standardized way, encoding to turn a character into a sequence of one and zeros. That's what encoding means. So they are the two most popular ones defined by Unicode is UTF-8 and UTF-16. Okay, now let's talk about UTF-16 because that is what JavaScript uses to encode characters into bits in JavaScript string. Okay, so when you have a string in JavaScript, it takes each character and convert it to 16, sequence of bits by UTF-16 encoding. Now the UTF-16 encoding the result of one character in UTF-16 encoding is either 16 bits or 32 bits. Okay, one of these two. When is a character encoded into 16 bits and when is it gonna be 32 bits? This is how. Okay, when a character whose code point is less than 2 raised to 16. Okay, when a character's code point is less than 2 raised to 16, then its encoding in UTF-16 is 16 bits. Okay, when a character whose code point, the integer ID, is greater or equals to 2 raised to the 16 power, then that character's encoding in UTF-16 will be 32 bits. Okay, so in other words, well, yeah, so that is what happens. So now let's talk about JavaScript strings code unit. So what does a code unit mean? So first of all, you take you are given a string. You take each character, you convert it to UTF. You take all the characters, convert it to UTF-16 encoding. Now some characters will have 16 bits, some will have 32 bits. If that character is the code point is beyond 16 bits. So you end up with a sequence of bits, ones and zeros. Then for every 16 bit, you consider them as one unit called code unit. Okay, so the first index of a string will be the first 16 bits. The second, index 2 will mean the second 16 bits, and so on. So that means for some characters, such as this smiley, which actually has a takes 2 code units to encode. So that means this character will not correspond to the index of JavaScript string. So that is why when you say this smiley length will be equal to 2, because this character actually has the encoding is 32 bits, so it has 2 code units. So that is why. Okay, that is why. Now on this page I explain in detail. You can read. Okay, let me read the comment a little bit. Well, okay, yeah, let me read the comment and answer the questions. So JavaScript code, Unicode encoding is the worst of both worlds. English and okay, what which okay, let me answer the question about surrogate code points. Well, they don't say surrogate code point, they say surrogate pairs. Okay, Norman asked about surrogate pairs. Now in Unicode there's a concept of surrogate pairs. So what does that mean? So remember we talked about in UTF-16 encoding, some characters is will have 32 bits, become 32 ones and zeros. So these 32 ones and zeros, so we have 2 code units, 16 bits each. Now this particular 16 bits is called a surrogate pair. It's one pair because these two 16 bits, these 2 code units makes up actually one character. So why is it called surrogate pair? I mean, first of all, it's a pair because it takes 2 code units to make up one character, to encode one character. And surrogate just means it kind of means they are together. But why does this happen? Okay, why does some characters needs two 16 bits? Well, because remember the characters that become 32 bits require 32 bits in a UTF-16 encoding are those characters whose code point is beyond 16 bits, 2 raised to 16. So obviously, you know, you know if you only have 16 bits, that's enough. That's not enough to encode more than 16 bits of characters. So therefore, they created this method to encode characters, to encode more characters. That is why some character will be 32 bits, and those characters are the characters whose code point is larger or equals to 2 raised to 16. So that is what surrogate pair is. Surrogate pair basically refers to these any of these 32 bits 32 bits, basically 2 code unit bit sequence that corresponds to those characters that whose code point is beyond 16 bits. And also, let me emphasize this. So the surrogate pair notion only happens in UTF-16 encoding. It does not happen elsewhere. Okay. Now remember, encoding is a process to turn a character into binary sequence, and Unicode defines 3 of them. You have UTF-8, you have UTF-16, you have UTF-32. Now UTF-32 is the simplest of them all. Every character it will become 32 bits, and that's it. So every character will have the same number of bits when it is encoded. It's the most simple one. But however, the problem, I mean, the disadvantage is that it takes, lots of space. It takes more disk space. It takes more memory to, process it. So, I mean, each of these encoding, UTF-8, UTF-16, UTF-32 has advantages and disadvantages. So it so happens that UTF-16 is used for JavaScript and as well for Java and C Sharp and in Microsoft Windows file system and also in Mac's HFS plus file system, I think. So anyway, so that's about encoding. That's about UTF-16 encoding. That's about surrogate pair. Now surrogate pair notion only happens in UTF-16. That's a good thing to remember. Okay, that's a good thing to know. It just refers to the code sequence that's from a character whose code point is beyond 16 bits. So 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 that's what surrogate pairs means. So okay, so what we're gonna talk about? So let me talk about, so why Unicode 16. I mean, why UTF 16? You see, this. So yeah, first of all, let's talk about UTF 16 a little bit. So which encoding to choose? Today it's basically UTF 8 is the most popular. It's the most widely used, and it's used by like 94% of the web worldwide. And basically, all web technologies, they the community today, the industry, the web programming community, the standards or HTTP, they converged into using UTF-8 as the recommend. They all recommend UTF-8. So UTF-8 is becoming the most popular. But as we know, technology does not happen. I mean, it's not. Back then in 1995, when JavaScript was created, UTF-8 was not there yet. I mean, it may have already been invented, but it's not ready. It's like when you have a new technology. For example, I created a new language. Okay, people are not sure. They will back you up unless everyone, all the big companies realizes, okay, this is not reliable. We want to use it. Otherwise, when something is new, people are not sure. We don't know. Maybe that tech will die. Unicode is actually one of the case. Back in 1990, for example, we don't know. Nobody knows if Unicode is going to survive. Over the past, technology, over the history of technology, lots of technology come and go. Perl is dead today almost. So at the time, you really don't know if UTF, Unicode. We should, it's like still a question, and also it's a question, whether JavaScript will survive. Who knows? Like Netscape just one day said, "Oh, we created JavaScript. This is gonna help you for your designers for interactive, dynamic, HTML and so on." But everyone is not sure. Microsoft is not sure. They have to make a decision. Every big companies, they are fighting all the time, right? Like Apple, Facebook today, Microsoft, Google, all the big corporations, they are fighting about technology. They want everyone to use their own. So it's a situation when there's a new technology, nobody is, you have to see whether it survives or not. So anyway, when JavaScript began around 1995, and also Java, they began about the same time. Java is a bit earlier. At that time, the common thought is that UTF Unicode will be popular. Unicode is already widely accepted. but however, UTF-8 is almost not on the scene yet. Okay, UTF-8 doesn't come. It came later. In the beginning, there's UTF-16 and UTF-32. Okay, there are just these two. So back then, at the time, UTF-32 will take lots, like two times or four times disk space. So people are not sure about that. So obviously people are thinking UTF-16 is a right choice. Because remember back then, internet just began. This is 1995. Internet, there's only a few hundred websites, something like that. And and most people are using ASCII. Like most people have no idea what the heck is Unicode. And it's not common to see other languages because there's no internet yet. I mean, it just began. So USA lives in USA. Germany is in lives in Germany's home bubble. Japan is in Japan's bubble. Like there's not much communication yet, except in printing, like newspapers. You have to ship it, fax. So back then, we are most people are still using. People are just beginning to start to use Unicode, and most people are just know ASCII, which is 8 bits. So to most people, we think 16 is, oh my god, now we have 16 bits. That's plenty. That's like enough, enough until kingdom come. So everyone just adopted UTF-16. That is the original history. Okay, that is how UTF-16 became in so many standard systems. But not until later on, until like 2005 or later, people begin to realize 16 bits is not enough to encode all the world's languages and so on. So and UTF-8 is a interesting story by itself. UTF-8 is, I despise UTF-8. Okay, I know because yeah, you guys probably know. You guys are probably chanting for UTF-8 because it is from the Unix. If you love Unix or Linux, you love UTF-8 because there's huge amount of propaganda. They want to, UTF-8, they come up mostly because they became so popular today, mostly because backward compatibility with ASCII. Okay, what does that mean? Meaning that if you have a file and if you do not have any Unicode, non-ASCII character, if you encode it in UTF-8, and if you also encode the same file in ASCII, the two files will be identical. So meaning that as long as you don't have any Unicode characters, strange smileys or whatever, it's compatible with ASCII. It's the same encoding as ASCII. So UTF-8 is ASCII compatible, and that was a big advantage, especially for the Unix Fox and Linux because they all other corporations, Java, Sun Microsystems, which is dead today, Sun Microsystems, Microsoft, Apple, they are corporations. They have money. They sell products. They make money. If they products don't sell, they die. There's no ideology. They have to sell it. If people don't buy, they disappear. Like Sun Microsystems with their Java. So Apple and Microsoft and Sun Microsystems, and so they want UTF-8, so they created. But Linux, the ideology open source, you don't have resources, you don't have people. So if you want to support Unicode, that means you have to almost rewrite all your Unix kernels, your Linux or Unix kernels, your bash tools, the bag of tools. You have to rewrite them all because in encoding, you cannot use ASCII anymore. So that is a serious problem. If UTF-8 did not begin, okay, did not gain alive, then basically Linux may not be alive today. That's kind of one possibility. So anyway, so the Rob Pike and friends, the Unix people, they invented UTF-8, and that solved the problem. And Linux and Unix people loved it because with UTF-8, now to create your Linux to bash or the whole Linux package to support Unicode, it's not a huge task anymore because it's compatible with ASCII. You just patch a little bit to support characters. So anyway, that's a story of UTF-8. But anyway, so back to JavaScript, but about UTF-16. So JavaScript strings are technically, the definition of a string is a sequence of UTF is a sequence of 16 bits called code point. I mean code unit. Code unit. Okay, so each 16 bit is a code unit. And when a character whose encoding in UTF-16 has 32 bits, then you start to have this problem because the index does not correspond to the characters. So that's okay. So that's a problem. That is why all Java. So whenever you have a string, and if your string contains a character whose code point is beyond 16 bits, you have problems. Meaning that all string functions or string methods will break. It's a serious problem. Can you imagine? Programmers. Hey, good evening. Am I? So that's a serious problem. So I'm very annoyed about this problem. Okay, so I asked. JavaScript started to have a standard, a new version every year since 2015. So there's this question in my mind. This is a serious, heavy problem. Because by the way, it's not just emoji that creates a problem. It's any character whose code point is beyond 16 bits have this problem. Now, what characters that whose code point are more than 16 bits? Okay, so almost all emoji has more than 16 bits, and also lots of Chinese characters, like rare, less frequently used Chinese characters, and and any basically, there are thousands of them. So so this is a practical issue in JavaScript because now when you have a string, first of all, as a programmer, you write web applications or whatever. When you have a string, you must have first of all be aware that does my string contain any characters that's beyond 16 bits? If no, if no, then okay, I don't have nothing to worry about. I use string functions. But if it does contain a character whose code point is beyond 16 bits, then I got a problem. I cannot use all the built-in methods and functions. I have to kind of work around. Imagine you have a language where all string processing functions, which is the core of the language, is broken. So every time you have a string, you have to know, does my string, contains any particular character? That's a serious problem. But the programming fucking idiots, I cannot imagine. They don't, no. I talked to in my years of programming experience, 20 years. I talked to all these programmers, especially the Unix and Linux fuckheads. They almost always never see the problems I see. Like, for example, this example about JavaScript. To me, it's like a huge huge problem. But whenever you talk to industrial coders, especially the elite, they talk about Unix philosophy and whatever jargons or patterns or they like my interaction with them, I always find that they don't see whatever I find is a big problem. They don't find it a problem for some reason. Okay. So anyway, so in my mind, this is a big problem. And JavaScript, starting in 2015, they have a new version, new standard every year. Each year they add little things. They fix lots of problems. So in my mind, what are they going to do with this problem? Are they going to fix it? That is a big question in my mind for a few years. So I yesterday finally I asked the guy Brendan Eich, who created JavaScript. Okay. By the way, JavaScript is now there's a design committee called TC39. Okay, something like that. Let's go back to okay. So I asked the Brendan Eich. Okay, you can see the Twitter Twitter fuck. So let's show you the thread. Okay, now on Twitter, the threads are disconnected. But so anyway, yesterday I asked him the question, and people finally I got answers, and people start to discuss it. So you can see this is the URL. You can go there, read it, and you can link to. I mean, you can. Let me paste it here. Okay, by the way, Twitter thread is not well connected because there are much more posts than what you see here. It's more than 10. So you have to put focus on a thread. Then, for example, this thread has two answers, but you can only see one. You have to click on that post. Then you can see the other posts related to that thread. Okay. So anyway, so this is not all you see, but anyway. So yesterday I asked Brendan, okay, Brendan Eich, who created JavaScript in 1995. But however, by the way, JavaScript is not today. It's not like under his control. He basically, I don't think he actually has any control. He can only recommend and discuss. Basically, they have like non-profit standard committee called TC39. You'll see it if you follow this thread. Try to see all the posts because they are like yeah, Twitter is got a problem because it's hard to find all the posts related to this thread. Anyway, so anyway, so I asked Brendan, and although he is not controlling JavaScript design, but however, he's heavily participates in the process. Because his opinion people still respect. So finally, and he also linked to a bunch of people in the JavaScript design committee, who works at Google and so on. And another guy called Fake Unicode. He's on Twitter. He's actually one great guy. Okay, he knows. I learned a lot Unicode from him. There's this. Well, let me show you the. Just for fun. Fake Unicode. Okay, this guy. There's a account called Fake Unicode. So I know him on Twitter for like 3 years by now, and I have learned Unicode from him. Many esoteric technical details. Now he doesn't say, and his handle is Fake Unicode, but he doesn't say what's his name or who he is or who he works for. But I'm guessing, I get a sense that he's actually working for the Unicode consortium. That's just my guess. Maybe he doesn't want to tell, but anyway. But yeah, he's a great guy. But anyway, let's go back to so yeah, he knows many esoteric details about Unicode. And let me show you the other guy who is in the JavaScript technical committee. His name is Matthew. This guy, okay, Matthias Binance. I came across this guy before, like 5 years ago. But anyway, he's so there's this thread, so, and they answered my question. So finally, so what is the answer? So my question is, why is there any plan for JavaScript to fix this string problem? It turns out no. you know, because they want backward compatibility. Okay, so they just decided they're gonna do nothing about it. Well, they are aware, of course, it's a problem, but to for some reason, okay, to these industrial people, they they just live with it. To me, it's like this is a fucking problem. We need to, to do all things possible to get it fixed, but not to most of these peoples. But they know it. Of course, it's a problem, but so their solution is actually, they have some solutions in the works, kind of that possibly will fix it. Okay, not certain yet. We don't know, but I mean, if you read the thread, you'll see it's called international segment. Okay, or international segmentation, something like that. You'll see it if you read the thread, which which is actually not fixing the problem, but we might evolve into solving this eventually. Okay, but anyway, to me, this is a serious problem. So, I mean, if they are right now, they don't have a plan to fix this. So, what does that mean? That means for forever, whenever, there are how many people code JavaScript? Millions, right? Because JavaScript is like almost the number one most popular language today. So for these millions and billions of software applications, websites, every time you use a string, you have this problem. Now, how idiotic is that? I cannot possibly imagine that people will say, "Oh, that's okay, that's no problem." I don't care what I don't care what is the issue. You have to uh, fix it, even if there's no solution other than break backward compatibility. But anyway, that's so that I think that concludes my explanation of the JavaScript string problem. And by the way, this problem happens also, as I learned from one of these guy. It also happens in Java, and it also happens in C sharp. Now, if you look at this code is Java, okay? It also have the same problem. You have a smiley, and the length is 2. And also, this example also shows that a method, a string method is also broken, just like JavaScript. And here is an example from C sharp language, the same problem. So, so to me, so I have lots of problems with the programmers. Many of them call me a troll. Now this is one example where you can see a difference. I cannot, it's just a difference of the way I see things. I cannot. I mean, these things are not acceptable to me. Doesn't matter. I don't. Well, I mean, of course, I understand. There's a historical context. I just explained the history of JavaScript and Unicode. So that is how we have the situation today. And backward compatibility is also very important. In fact, almost critical. So I do understand why JavaScript, string methods are broken like that. But however, this is like not acceptable to me. Like these people, I mean, today's JavaScript standard, they are thinking we're gonna just live with this forever. I mean, that's impossible. But anyway, Brenda, they do have logics. They give their reasons. Either we, for example, Brendan has said, either like he said, he mentioned that we have two choices. One, break all backward compatibility. Okay, meaning that if you change JavaScript, then all the website in history will be broken, including all those printed out on DVDs or CDs, in 1990s and 2000s. Now, that's obviously not, that's actually very critical because when you break things like that, it's also it has critical consequences because that's similar to erasing a big chunk of history too, because a lot of things rely on it. So yeah, I understand. So one way is break backward compatibility. The other way is just to create new features. So as time move forward, we use the new features. Now, so they obviously they decided to use just stick with new features. However, to fix this all this string method problem, meaning that either we have to create a copy, of all the string functions, like there are 30 of them. Okay, let's go to my JavaScript tutorial. Okay, let's go to JavaScript object reference and let's go to string prototype. So here's a tutorial. I mean, this is a reference on string prototype. So this shows all the string methods. They are like 30 string methods. So if we want to add new features, that means we make a copy, a new version of each of the string method. And that is also fairly ugly, right? So another option, I have thought about is that we create a new language directive. For example, if you code JavaScript, you know that we have this use strict. That's a string, just use strict. And if you have that in your JavaScript code, that means the compiler will treat your JavaScript in a different way, considering it as kind of a new language, not backward compatible. They created use strict around 2000. I think they created that. I forgot when, 2008 or something. But anyway, they didn't. They did not do a very good job. So even if you have used strict, it doesn't change much except some of the very bad things about JavaScript. So anyway, my vision, okay, my idea of a solution is we create a new directory. For example, use strict 2000, 2020. That means, in 2020 or 2019, we create a new language, kind of like backward incompatible, that fix all these issues. So for all new JavaScript code, we can just say, use, let's just say use 2020, meaning that, so if we do this, it can be backward compatible, but meanwhile, it can also, have more elegant code. But for some reason, again, these people, these industrial programmers, including Brendan Eich, okay, they think this creates more problems and more complexity. So therefore, they decided, the JavaScript team, the future team decided not to introduce any this called pragma or code directive. I think it's technically called pragma in JavaScript. Each language calls this kind of thing differently. In Perl, it's called directive. I think in JavaScript, it's called pragma or something. So anyway, they decided they don't want to do that. So okay, so that is the situation with the JavaScript. That concludes my discussion, my talk about the JavaScript string problem. Okay, in the comments, please don't swear. Okay, I don't care if we swear, but however, Google today, YouTube, they are starting heavy censorship. So if my channel has swearing words, they're gonna ban. You, they are going to ban my channel. I try not to. Um, so so let me read the comments, and then let's see. Maybe we can talk about the next topic. Now we've been talking about for an hour, maybe 10 more minutes. I think the technique. Now Aldo Aldo says, hi Aldo. Aldo says code unit came before Unicode. No, well, no. Well, the term code unit, the jargon code unit, is just a term that means 16 bits in the UTF-16 encoding. So, so first of all, you have Unicode, Unicode Consortium. Okay, now his history is a little bit complicated, but anyway, we can think of the Unicode Consortium, which is a nonprofit. They start the concept of Unicode, so that we can have all the world's languages, Chinese, Japanese, English, French, all in one kind of standardized encoding. So that's the idea, Unicode. They began in 1987 or something like that. So that's the idea of Unicode. So Unicode began. Then you have they also define encodings, right? So they define UTF-16, UTF-32 in the beginning. So in the UTF-16 encoding standard, publication, they define the jargon code unit, which means 16 bits of of a encoding. So that's my understanding of where the jargon code unit came from. Now, it may have history before this, but I'm not sure about that. But mostly today, when you say code unit, you pretty much means the UTF-16 16 bits. Okay, I'm not gonna answer every comments, okay, because there are so many. I think you're cemented. It's over. I like Daily Prague. What is Daily Prague? A website? Norman says. Okay, I forgot what's the context. Okay, even with UTF-8, things went downhill. So if I didn't answer a question, or I have questions about your questions, just type it again. I'll see it. Then I'll get I'll answer. Okay. So let me see the next question. So Todd says, "Good morning, Todd." Todd says, even with UTF-8, things went downhill after Unicode. Yeah, Unicode has become, in my opinion, the organization itself has become somewhat corrupted. Unicode today, since about let's say 5 years ago, it has become political issue. Why? It's strange. It's just a technical standard about characters encoding. Why is it political? Because emoji has become a huge political issue, because some people, they want skin colors, they want skin colors for everything. Then they want girls, so you have like a castle, then people say, oh, but then you have church, emoji, right? Then people say, oh, no, then you need a mosque emoji to represent Islam. Okay, then you need, then you, of course, then you need a Buddha temple emoji. Okay, so it becomes a big political issue of skin colors. Then it becomes also part of it is gender, sex issue. Like if you have an emoji of a face, Is it a female or is it a male? Okay, that's a that's a question. So you cannot have, if you have a dancer, a girl dancing, there's a emoji character called dancing. Okay, let me show you. Let me show you the emoji characters. Okay, so for example, if you have this emoji character, okay, let me go to Chrome here so you can see actually you can actually see the pop-up. For example, there is this emoji. Okay, it's called the name is dancer. Now emoji originated from Japanese phone. Mostly Japanese girls back in 2002 or so. Emoji came from emoticon. So well, I'm not going to go into the whole history, but anyway, emoji came from Japanese phone. Japanese, teenagers, they use phone, so they want to send pictures. People smiling, dancing, or eating Japanese food like sushi. Let me show you food. So these are some of the original emojis, Japanese food. Let me magnify. So in the beginning, you don't have all these hamburgers, bread. You don't have none of that. It's mostly just these Japanese here. So you have this Japanese rice cracker, Japanese rice ball, sushi. You have Japanese fish cake. You have this Japanese bento, which is kind of a lunch box. Uh, you know, so emoji originally is Japanese pictures, for icons used by teens on their phone around 2002 or something like that. And different phone companies they use different images. So it became, it came to the Unicode consortium's head that we can unify it. Wouldn't it be nice if Unicode created a standard, code point for these images so that each phone company don't have to, convert the image into some bits and transmit it, and that bits convert back to image, and different phone companies may not use the same image. For example, sushi on my phone looks different than the sushi on your phone. So the Unicode got the idea. They can create a code point for the emoji. So they did that. So remember, this is from Japan. Okay, this emoji origin is from Japan. Not in Japan, they don't have whatever fuck your notion of American notions. They are different culture. They don't have your notion of your justice or whatever. Okay, so in Japan they have, for example, let me show you an example of a derogatory thing, emoji originally from Japan, that is about Chinese. This one. Okay, the emoji name is man with guapi mao. Okay, so what does that mean? So you see this Chinese character face. Okay, this face got this hat. You may see the hat from Chinese TV drama or kung fu movies. Sometimes you see it. This hat is called guapi mao. Okay, mao means a hat. So what does guapi means? Guapi means it's like a watermelon. Okay, a watermelon or cantaloupe. It's like a melon. Okay, melon. You cut it in half. You got this semi-spherical thing. You put it on your head. So that hat looks like that. So in Chinese, we call that guapi mao, or melon hat. But it's not something we like to we like to associate with. It's more like that's history of China. Okay, and especially its history in an era where it's not we Chinese are not proud of that era, because foreign invasions and Japanese invasions, the Qing dynasty. Okay, you have this hat. But in Japan, Japan had Japanese war with China. So anyway, Japan, they created this emoji. They okay. So in Asia, we don't care much about I mean, anyway, Japanese, they created this emoji on their phone, so they did that. So anyway, the origin, that's the origin. So this is one of the first. This, for example, this character, man with guapi mao, is also one of the first emoji. It came from the Japan. All these others you see here are new. These fairies and wizards and anyway. So what I'm saying is that, okay, so emoji. So why is it became political? Okay, let me explain. So let me show another. Okay, this dancer is also one of the original emoji from Japan. Okay, so you have a dancer. It's a girl dancing. In red skirt. It's like very, uh, flaming. It's like sexy. And also this character, women with bunny ears, showing two girls. With bunny ears. It's like Playboy bunnies. Okay, it's nothing like what you see today. It's originally in Japan. It looks like two Playboy girls, meaning sexy, like doing club dancing stuff. Two women with two bunny ears. This one is also one of the original Unicode character from Japan, emoji. So, but anyway, so look at this dancer emoji. Now to the Western political, today, like, okay, you have a dancer, but why should it be female? So the white people want to ask, so we should have, it should be male too, because this or that. So they created men dancing, and so for example, any character, for example, this baby. So since 2005 or so, every year Unicode added more emoji. For example, now today we have hamburger, we have pizza, we have Western croissant, French croissant, we have cheese, eggs, all kind of Western food. Then we also added Chinese food, Chinese chopsticks, and so on. But before, it's all these are not there. You just have the Japanese, basically these ones, about maybe 5 or 10 of them, because that's the origin. Japanese teenagers, they use their phone. you know they are not thinking, oh, we must be fair, we must represent all the food in the world. They just want, they show sushi because sushi is, I don't know, food that they eat often or something like that, right? So anyway, but to the Westerners, so when you have a baby emoji, some of the people are thinking, oh, but should the baby be male or female? Oh, wait, we need a baby with black color skin. We need a baby with red color skin, and so on. So today it becomes a very heavy emoji political issue. And for example, you have this picture, men with women, men and women holding hands. I don't know if this in the original Japanese emoji. I don't remember. But anyway, but to the Westerners, then it's, their thought is become, oh, but but then we need men with men holding hands. Then we need women and women holding hands and things like that. So everyone, it becomes very political issue. So so that is why. Okay, that is the situation. And in fact, today we have come to the point that the Unicode consortium, they decided they decided that all emoji, they should not by default associated with a sex. You cannot, if you have an emoji, you cannot have, it's not supposed, it cannot be either male or female. It has to be like neutral. For example, look at today's emoji. Okay, I'm on an Apple Mac OS. Look at this emoji. It's like almost all of them become so this. They don't look like men. They don't look like women. They don't look like a girl, and they don't look like old men. They don't like. They all become this generic, extremely generic and creepy thing. That's this social justice have created. they all become this extremely creepy face. And look at this. So in the past 2018, I think 2017 or 2018, we added a bunch more emojis. So you have this mer person. What do you think of a mermaid? Mer person came from mermaid. Mermaid is has long history, like 2 or 3 thousand years ago from Greek mythology. You have mermaid, and it's always mermaid. You have statues of mermaid. That's 1,000 or 2,000 years old. But today, in the social justice era, you cannot have a mermaid because that would be, that would be mythology or whatever, a stereotype or whatever. So you have to have a character that's you cannot have merman either. You have to have a mer person. And look at this thing, ugly, extreme ugly thing. What is this, merman? This, not like a man, not like a boy. You have this. So and then you have this elf. Then this, look at this genie. I mean, does that reminds you of a genie? I mean, genie has Asian history from the Middle East. Okay, now of course when we think of genie today, we think of Disney's genie. Okay, that's just Americanized genie. Genie is a fictional creature, mythology in Middle East. Okay, I'm not sure exactly what's the region, but it's not like Disney's version. But then you look at this emoji version of Genie on Apple platform. It looks very creepy. It looks like nothing. It looks like a semi zombie. It looks like a semi boy, and it looks like all this becomes creepy things. And this Manch, look, anyway, I think you get what I'm saying. That's a political situation of Unicode. And the social justice people, they are doing these things all day every day now. Okay, no, you do have a different skin color. Like I mentioned, Unicode has become so corrupted and complex. You have skin color, but to do that, you add another character called a variant. Now you have like 16 of them, 16 variant code point or characters. So if you place that character adjacent, right after the mer person, then you'll get the male or female. And also, I think there's also skin color. So it's like, anyway, it becomes very complex. Unicode has become, this political situation and very complex. So let me. So I've been talking too long. I think I've been okay. I think that's it for. I mean, that's about it. So if you have more questions, ask it, and we are done. And we are going to skip the math, the talk about logic, modal theory, and stuff. So let me finish answering the comments, and that would be a good talk today. So Norman asked, does direct indexing ever make sense for Unicode? I think you must process the entire string to find all grapheme clusters. No, I think yes and no, depending on what you mean. But okay, so I think what you are asking is about more complicated problem, because, well, I'm not going to talk about that, but I think, but anyway, let's so if you let me point out for all those of you, JavaScript. So search for JavaScript, INTL segment. Okay, that is the new proposal in JavaScript to find the boundaries of graphemes in Unicode. Okay, I think that relates to what you are asking, Norman. So you might check out this page, that discuss that in detail, and also for different languages deal with the Unicode problem in different ways. For example, Python 3, they created a way so that every string in Python 3 is just Unicode characters, Unicode code points. That's it. It's not bits, it's not bytes. Every element in a string of Python 3 is a Unicode code point or character. Okay, that's how Python 3 deal with the problem, and which I don't think is a good solution because they created lots of problems. I don't really know the details, but anyway, they a lot of people don't like it. And by the way, also let me mention Golang, which is my favorite language. They solve the problem in another way. Let me find the my Golang page. So if you go to Xali Golang tutorial, you can see I discuss how Golang solves the problem in this page. 等一下，我现在有事。我不吃了，不吃了。So Golang solves this. My roommate asked me to eat. So Golang solves this page, solves the problem. So in Golang solves deal with the string problem and Unicode in a different way, different from JavaScript, different from Unicode, different from JavaScript. 我等会来吃，等会吃。Different from JavaScript and different from Python 3. Okay, so in Golang, a string is a sequence of bytes. A string is a sequence of 8 bits. That's it. It's not about Unicode. It's not about characters. It's simply a string in Golang is sequence of bytes. 8 bits. so but how do but what if I have a smiley? What if I have an emoji in a string? Well, you can still solve the problem. Anyway, I'm not going to explain about that. You can read my website if you like to. I kind of have to go because my roommate is calling for me. So folks saw stories at Wolfram. Well, I kind of heard of Nim. I think it's a great language, but I don't have time to learn it. Yeah, I heard many people telling me. So Nim is kind of a language, kind of like in the same class as Golang. It's very very fast. For you can use it as a system programming language, but meanwhile it's also elegant. I think the syntax is Python, right? It's a Python based syntax, but however, it's also typed just like Golang, very efficient. Oh, Unicode in Emacs, that's another very interesting. It's Emacs is the most wonderful language when it comes to Unicode. But anyway, I gotta go. So thank you guys for coming by. If you like to support me, just go to Xali blog. Okay, any of my blog. I got Patreon. PayPal. You can Amazon gift card. I appreciate that. Okay, thank you guys for coming. It was a great talk today. I'll see you guys next time. If you got a comment I didn't answer, post in YouTube comments. Then I'll see it and we talk about it next time. Thanks. Good night, guys.